In the previous example, we were shown a scenario in which three different banks offered different interest rates at various pay periods. And we saw how compounding can affect the interest rate. This effect that compounding has on an interest rate is known coincidentally as the effective rate. The effective rate is an actual annual rate someone earns due to the effects of compounding. So we know that a future value, FV, that's equal to the principal, times 1 plus the rate, and then that's divided by the number of compounds, pay periods, raise it to the n times t power. And we saw that this portion right here, this is the portion that we have to multiply to the principal p to determine what our future value is. So p depends upon what this is right here. So this is what's going to affect the principal. So the effective rate, E, we just label it as E, is equal to this. 1 plus R over N times T. Now, since this has to be a rate, this has to be a percentage. A percentage means per 100. So since this has to be a per 100, we have to subtract out 1. So for this scenario, it says, what has a greater annual, that's where t is equal to 1, rate of return? An account that earns 4.65% annual interest compounded monthly, or an account that earns 4.75% simple annual interest? So this equation here is going to show the effect that it has on the 4.65%. So we determine that. So E is equal to 1 plus R, and R is 4.65%, 0.0465. We divide that by the number of pay periods, the compounding, that's monthly. So then this gets multiplied so many times throughout the year. How many times does that get multiplied? Well, it's monthly, that's 12 times. And the length of the loan, well, for here, it just says t is equal to 1, so we're just going to leave it as 12. And then since this has to be a percentage, we'll subtract out 1. So right here, we'll go ahead and we'll put this in our calculator, straight into our calculator. We've done that before. 1 plus 0.0465, divide that by 12, and then we'll raise that to the 12th power. Hit enter, and this is what we have. But we need a percentage as a per 100, so that's where we subtract out the 1. So I'm just going to say minus, there's that ANS, minus 1. So this is approximately 0.04750,394. So the effective rate is approximately equal to 4.75%. So what does this say? Well, this says that the advertised rate here, this is the nominal rate of 4.65%. It's compounded, since it's compounded monthly, it's actually going to pay 4.75% at the end of the year, which is the same as 4.75% of just simple annual interest. So there's the effects of compounding.